Hello students, so now we're going to solve part B. Data book value for standard enthalpy change of combustion of methane is minus 890 kilojoules per mole. What is the experimental value for the enthalpy change of vaporization water in kilojoules? We know that the enthalpy change of combustion in gaseous state is equals to combustion in liquid plus vapor. So all these values are already given to us. We know that the enthalpy change of combustion of water in gaseous state is 810, which is given in the previous part of the question. If you look here, this 810 is already given to us, so we're going to place this value, and there's another value that is minus 890 given in the vapor state, so we place this in the value, and the answer is 80. Why we have divided by 2? We have divided by 2 because basically the values given is for 2 moles of water, and to find out the vaporization of water we always consider for 1 mole. That's why we're going to divide it by 2. So the answer is 40. So the correct option is B. Moving on to the next question, which amine with molecular formula has the lowest boiling temperature? So we know as the smaller the chain, the lower will be the boiling point. So if we draw all these structures, the only structure that gives the smallest carbon chain is option A. So A is going to be the answer, and the reason behind this is because it's going to have low London forces of attractions. Okay, now we have question number 4, that is aqueous solution of potassium chloride is added to a solution of iodine in hexane and shaken. After time 2 layers are formed. What is the color of each layer? So here we're going to use a separating funnel in which we are going to pour this mixture, and obviously the water is denser and iodohexane is lighter, so it will be on the upper layer, upper side, and we know that iodine in water is going to be yellow, but here in liquid form it's going to be purple. So because iodine is more soluble in hexane, and you know that iodine is a non-polar, hexane is a non-polar solvent, so you know that like dissolved like, iodine is non-polar, hexane is non-polar, so it will be soluble, forming a purple color. So that purple color is found on the upper layer, and water is going to be denser, but some of the iodine might mix in the lower layer, so it's going to be yellow. Because here we have got 2 options, either it's going to be A or it's going to be C, because C we have lower layer that's colorless completely, and that's not possible. So purple and yellow, yeah, A is going to be the correct answer. Then we have question number 5. What is the correct order of increasing oxidation number of nitrogen in these ions and compounds? So here what we're going to do is we're going to find out for the first one, nitrogen, what is the oxidation number of nitrogen in here. Because we have 3 hydrogens, we multiplied by 3, it's minus 3, and in order to get 0 overall, because the compound is neutral, so here we're going to place plus 3. And for nitrogen and oxygen, nitrogen oxide, here we have minus 2. We know that the oxidation number of oxygen is minus 2, so here it becomes plus 2. Similarly, here we have already got minus 1. The overall ion is minus, so in order to get that, we have got plus 5 value for nitrogen. So if you look, you don't need to solve the rest of the part, because here we got there's an increase in the oxidation number, plus 3, plus 2, and plus 5. Moving on to the next question, that says the most common source of iodine contain the iodide ion. Iodide ion reacts with iodide ions in acidic condition as shown. The forward reaction is best described as. If you look at the equation, we can see here what happened. There's a minus 1 in iodine, and it becomes 0, so that means his oxidation is happening. And then we have another, if you look at this another ion, that's here what we see, there's a plus 5 oxidation number for iodine, and it converted into 0. So here reduction, because both reduction and oxidation is happening, so that's why it's going to be redox. It's not going to be disproportionation. Why? Because in disproportionation, the same element is going to be oxidized and reduced. Here the two different species are going under reduction and oxidation, so this is going to be a redox reaction. Moving on to the next question, which electron movement caused the yellow color produced in sodium chloride flame test. So always remember, whenever the electron gets extra energy, initially they were in a ground state and they move into the excited state, and once they move into the excited state, they come back into their original state from which it has moved upward. So here what is going to happen, it's going to emit certain colors. So in this case it moved from, initially it moved from S to P, and then when it come back, it's from P to S, it's going to be emit the colors, and that colors are going to be absorbed in the visible spectrum so that we can see the color changes. Okay, then we have another question that says 20 gram of an impure sample of calcium carbonate is heated and decomposed completely. 3.6 decimeter cube of carbon dioxide is produced at room temperature and pressure. What is the percentage purity of the sample? Assume that impurities do not produce carbon dioxide when heated. So writing down the equation, we get a calcium carbonate gives you calcium oxide and carbon dioxide. Here basically we're concerned with calcium carbonate and carbon dioxide only. So we have to find out the moles of carbon dioxide. That's very simple. The volume that is already given to us, that is 3.6 dm cube. So we divided by 24 molar gas volume, which is also given to us over here. Because we don't need to change the units because both of them are in dm cube. So now we have got the moles of carbon dioxide, that's 0.15, and we know the molar ratio from the equation, it's 1:1. So the same will be the moles of calcium carbonate. So once we found the moles of calcium carbonate, that now we have to find out the moles of calcium carbonate in 20 grams because the sample is of 20 grams. So that's why we have to divide by the MR of calcium carbonate, that's 100. So we got 0.2 moles. And now placing the formula, that's the you need to learn the formula. That's percent purity is equal to pure upon impure into 100. So what is the pure? The pure is the one that we have calculated from the above equation over here, from the equation, that's 0.5, and 0.2 is from the sample that we have. So basically it's the experimental one. So 0.15 divided by 0.25 multiplied by 100 gets 75%. So D is going to be the correct option. Now we move on to question number 9, and it's about basically experiment to measure the rate of reaction. A sample of magnesium ribbon, we have got magnesium ribbon of mass 0.25 was added to 25 centimeter cube of sulfuric acid of concentration 1 moles per dm cube. So basically you have two experiments. This is the first experiment, then we have second experiment in which we have used magnesium in form of a powder. So what they are asking is what are expected differences on observation in the second experiment. Obviously because it's in a powder form, so it will have more surface area to volume ratio, so more the rate of the reaction obviously will increase. But the total volume of hydrogen produced is not going to change. Why? Because we have used the same mass of the reactant. The magnesium is of same mass, so that's why hydrogen gas will be same. So coming back to the option, C is going to be the correct option. Now moving on to question number 10, which is which change increases the proportion of particle in reactions that have a sufficient energy to react? Obviously only the temperature. Increase in the temperature is going to be the correct answer. Now moving on to the next question, we have in production of sulfuric acid, oxide reacts with oxygen to form sulfur 6 oxide. The equation is given in a closed system. The is allowed to reach the equilibrium. Which of the following statement must be correct? So the reaction stop, obviously it's in equilibrium, so it will not stop, do not stop. And the sum of the mass of sulfur oxygen is equals to the mass of not required. Actually we are looking for which statement is correct. Okay, so the rate of formation of sulfur 6 oxide is equals to the rate of its decomposition, right? So whatever the only possible is to find out the production of sulfur 4 oxides when it reacts with oxygen. So the only correct option is C. That's the rate of formation of sulfur 6 oxide is equals to the rate of its decomposition. So whatever it is decomposed into, it will directly affect the formation of sulfur oxide. How does the use of catalyst affect the equilibrium? You know that there is no effect on the position of equilibrium because of the catalyst, because it's reacting on both forward and backward reaction at the same time. Okay, moving on to the question number 12, the questions about organic compound containing 4 carbon atoms. Which compound has a peak in its mass spectrum at mass per charge 74 and 45? First, you have to find out the mass per charge, the MR, for all these 4 compounds. So basically, what we have got is butanone. All of them are not going to have the MR of 74. Basically only this third one is going to have the MR 74. We have to calculate like this: the MR, the mass of carbon into number of carbon, how many carbons we have to count the carbons in the structure, and then we have to write the MR for it. And then same goes with hydrogen, and same goes with oxygen. We have got only one molecule, one element of oxygen, so we have to the atomic mass of oxygen is 16, so we have to add these all. So we got 74. None of these have got the MR 74. It's not there. This one only have got the MR 74, but we won't get any peak at 45 for this, because how we're going to break it, it shows. So the only correct option is C, because if you break it from here, you get a one fragment that is the mass per charge of 45. So C is going to be the correct option. For this, you have to calculate the mass spectrum of all the MR of all these structures that's given in the question. Which compound can be oxidized to form a ketone? So basically, ketone is formed from a secondary alcohol. So you have to find out from all these option A, B, C and D which one is the secondary alcohol. So by looking at the name, we will find that first one is a ketone, because it says ONE at the end, so that means it's a ketone, and it's aldehyde. AL is at the end, so it's aldehyde. OL and OL, both of them are alcohol, but now we have to find which one is the secondary alcohol. So butane 2-ol is actually the secondary alcohol, so this is going to be the correct one. Why D is not correct? Because it's not secondary alcohol, it is the tertiary alcohol. Moving on to the next question, it says which compound forms a red precipitate when warmed with the Fehling solution? So it's always the aldehyde, and from all 4 options, the only aldehyde is butanol. Okay, moving on to the next question that says halogenoalkane RX reacts when warmed with aqueous silver nitrate in presence of ethanol. The rate of reaction of 1 chlorobutane, 1 bromobutane and isobutane was compared. The rate was fastest with ido and slowest with chloro. So which is the best explanation for result? As we go down the group, remember when we are going down the group from chlorine, bromine and iodine, the size of the anion is also increasing. So as we go down the group, the bond length increases, and hence the bond strength decreases. Because the bond length is increasing, that is making the bond weaker. So as the bonds are weaker, they react very faster. So the only correct option is carbon halogen bond strength decreases going down the group, that makes it to react faster. Okay, so moving on to the next part, which what is observed when 1 bromobutane is warmed with aqueous silver nitrate in the presence of ethanol. So here you need to learn the color, a cream precipitate. Remember when we are reacting it with the bromine, it's going to form a cream precipitate, and that precipitate is always soluble in concentrated ammonia, right? So basically, if you talk about ammonia, it's going to be insoluble in dilute aqueous ammonia, because it's soluble in concentrated one. Moving on to the next part, what is the mechanism of these hydrolysis reactions to form alcohols? And you know that we have a nucleophilic substitution reaction. Here OH is a nucleophile that acts on this carbocation and then it forms an alcohol. Thank you. That's it from the MCQ part, and we'll move on to the next part.